Okay, so it's time to get started. Hello, everyone. Welcome to today's session with myself, Emma Goddard, and our guest speaker, Susanna Lybæk. Before we get started, I just wanted to let you know the setup. We're going to be leaving time for questions at the end of the talk. So if you come up with any questions as Susanna is speaking, just click on the Q&A box at the bottom and you can submit your questions there. You can also see other people's questions and upvote them as you read them if there's any that you particularly like. The questions with the highest votes will be answered first. The questions will be moderated by me, and whilst we will try to get to all of them, if that's not possible and we run out of time, we'll make sure that we get these answered when we post it on the YouTube channel. So don't worry, none of your questions will be left out. Okay, so without further ado, let's get started. I'd like to introduce you to Susanna Lybæk, who is a zoologist with a passion for fish welfare and has worked as a scientific advisor at the Norwegian Animal Protection Alliance since 2012. She will be talking to us today about salmon, louse and cleaner fish. So over to you, Susanna.
Thank you very much for the lovely introduction, Emma. And thank you so much to the organizers. Thank you to Vicky and the Humane League for inviting me to talk about this topic, which I'm so passionate about. So I'm very happy to be talking about cleaner fish today. So let's begin. Before I get into speaking about cleaner fish, I thought I'd introduce myself because I'm not sure everyone knows who I am just yet. I am a zoologist. I've worked at Reliance, the Norwegian Animal Protection Alliance, for the past 10 years, and I work mainly with fish in aquaculture. I also work a bit with animals in research, and the reason for this is that Norway is actually the largest user of animals in research in the world per capita, and this is largely due to salmon aquaculture using a lot of fish in research in order to increase profitability and increase production. Our organization has a staff of 19 dedicated professionals at the moment. There are biologists like me, we have veterinarians, etc. This allows us to have a major expertise in our prioritized areas of work, which is animals in industrial production and also animals in research. And the reason why we focus on these animals is because this is an area where we see a large potential for improvement, and we work within Norway because this is where our expertise is. So today, I'm going to tell you about the fairy tale about the overlooked and ill-fated soldier on the front lines of aquaculture. Now, this fairy tale takes place in the Kingdom of Norway. In Norway, fish farming of Atlantic salmon is a very large industry. Norway is actually the largest producer of Atlantic salmon in the world. We produce more than half of all the Atlantic salmon that's farmed. 95% of it is exported. And this is the reason why my organization, Alliansen, focuses so much on salmon. We see a large potential for improvement because it's a very large number of individual animals. Also, it has the benefits that the industry is very flexible and very quick to adapt to new circumstances. So there's a very large potential for change. And it's also quite an affluent industry, and it can afford to invest if motivated to do so. As you can see from this figure, Norwegian production levels have reached a plateau in recent years with not much growth. This is largely due to one player limiting the industry. And if this story is a fairy tale, then I believe that the salmon louse is one of the big bad trolls. And usually in Norwegian production, you have over 1 million salmon per fish farm, and you have several hundreds and thousands of these lice, female lice, per farm. With several fish farms per fjord, these can produce millions and millions of eggs. Once these eggs hatch and drift away with the current, they can infect other farmed fish, and also they can infect wild fish. Now, as you probably know, wild salmon begin their lives uprivers in freshwater, and as they develop, they migrate out to the sea. But in the fjords leading out to the ocean, they must pass by these fish farms and these millions of salmon louse larvae. And this can lead to very high infestation levels and high mortality for the wild salmon. Now, because of this, In order to limit the effects of salmon farming on wild salmon stocks, the traffic light system was introduced a few years ago. This divides the country into 13 production zones, and each is given a color depending on the impact of the impact on the wild salmon. And this is based on sampling wild fish, locations of fish farming sites, models of ocean currents, etc. The sole indicator of this light is the impact of salmon lice on wild salmon. If given a green light, the production area is allowed a 6% increased production. Yellow light means the production must stay put. And if given a red light, then the farmers in the area must reduce their production by 6%. Now, the level of production is obviously very closely linked to profitability, which means that this results in a very high motivation for reducing salmon lice. This has led to innovations in methods for reducing salmon lice. There are preventative methods such as skirts, snorkels, closed systems, functional feed, fallowing, and many more. There are even lasers where you shoot a laser beam on the louse. There are medicinal treatments where you put chemicals in the water, for example, and this will kill the lice. The lice are increasingly developing resistance to these chemicals, so they're becoming less effective. There are mechanical treatments where you spray or brush the lice of the fish, thermal treatments where you use hot water to kill the lice, freshwater treatments, and of course, cleaner fish. Now, if you've never heard of cleaner fish, then you're not alone. Many haven't heard of them. So just to give a very quick explanation, this is a picture of a potato cod. It's being cleaned by two striped cleaner rats in a coral reef outside Australia. And this is a typical image that I'm sure many of you have seen in nature documentaries. These little cleaner fish cleaning parasites and dead skin cells and such of larger fish. And this is essentially what is attempted to be recreated in salmon farms. You have the salmon, they get infested by lice, and then you add smaller, cleaner fish that are meant to eat the parasites and the salmon lice off the salmon. Several different cleaner fish species are used. There's the family of wrasse species, and lumpfish also are being used. Now, it's worthy of note that none of these species are actually specialist cleaner fishes, unlike the tropical wrasses I just talked about, but they do opportunistically consume lice in tank environments and in cage environments. Now, in terms of cognition, cleaner fishes are quite advanced. We've heard a bit about this earlier this week, but just in case some may have missed those talks, we know that they can be very advanced in their cognition. The ability to perceive and recognize a reflected mirror image as yourself is considered a hallmark of cognition among many species. And since the 1970s, the mark test has been used to see whether animals have something similar to our own self-awareness. The validity of the test has been controversial for several reasons, but the test itself is very simple. The animal to be tested is anesthetized. A colored spot is painted on the face or an area of the animal that it can't see for itself. And when the animal wakes up, it can look at itself in a mirror. If the animal eventually begins to examine the foreign mark on its own face, it means that it can probably recognize itself. And this is interpreted as a sign that the animal is self-aware, or at least aware of its own body in some way. Basically, the animal realizes that it's not looking at another similar animal, but it's looking at itself. Now, in human children, about 65% manage this at the age of 1.5 years. Some manage it earlier, some manage it later. Several other animal species have passed the test, such as elephants, dolphins, chimpanzees, and crows. Several species of monkeys have so far not passed the test, nor have dogs. But for fish, this was tested on a wrasse species. They were marked and allowed to look in the mirror. And when they did, they swam over and rubbed on substrate. They rubbed the mark that they could see in the mirror on substrate. And then they went back to check if the mark was still there. They didn't do this if they didn't have access to a mirror. and they didn't do it if the mark was invisible. So this indicates that they recognize the mirror image as their own self and not as another fish. Now in nature, as I mentioned, wrasse often work as cleaner fish. This transaction between client and cleaner fish is actually incredibly complex. And studies have shown that clients like to visit the wrasse several times a day, and that one wrasse can have over 2,000 clients in one day. And they can recognize individual clients. But it's risky to be both a client and a cleaner fish. For cleaner fish, there will always be the danger that the client will simply try to eat you. For the client, there may be a danger that the cleaner fish will exploit the opportunity and take a bite out of your scales, or maybe your nutritious and delicious mucosal layer. And because this cooperation and trust is essential, a client-cleaner fish relationship builds over time. The fish that have been shown to be reliable and behave properly build a good reputation and are preferred by others. I like to kind of think of it as sort of a rating system inside the heads of the fish, where they give 5 stars to those who have treated them well in the past. And the cleaner fish also know if they are being watched. So if they are being watched, they will do an extra good job to impress other potential clients. Now, these fish have actually also shown culture and tradition. Wrasse have incredibly advanced social lives. And in a study on wrasse in a Caribbean coral reef, the researchers were surprised when they found that the fish show culturally conditioned mating behavior. They choose specific places for mating, and these places have been used for generations. And they are an example of tradition that is being used over years and over generations. And this is actually a learned behavior. And this Caribbean wrasse is actually a relative of the wrasse used in fish farms to remove salmon lice from salmon. But the Norwegian wrasse species are also very closely linked to the areas that they live in. Local stocks show specific adaptations to their home area. And so it's extra problematic when the aquaculture industry catches such wrasse and transports them across the country to completely new areas. And no one knows what happens to the wrasse that escape or the wrasse that are released from the farms. Now, this is just to show why we focus on cleaner fishes. They are actually the 3rd largest group of animals in Norwegian production. They by far outnumber the number of laying hens, sheep, and cattle all put together. But yet they receive very little attention. They are quite an overlooked group compared to how large of a group they are. Use of cleaner fish has increased in recent years. Around 2012, the industry felt the effects of salmon lice resistance to medicinal treatments. So they've been looking for new methods of salmon lice control. Cleaner fish were hailed as a biological and environmentally friendly solution because they bypass the need to release chemicals into the sea. So use has increased over the years, and in 2019, a total of 61 million cleaner fish were released into Norwegian sea cages, and this excludes all those that died before then in transport or in hatcheries. So it's a very high number. About 30% of them were wrasse, almost all of which were wild caught. It's quite rare still to farm wrasse. And about 70% were lumpfish, which are all farmed. So just to have a look at how cleaner fish welfare status is today, I would like to point out one of the potential heroes in this tale of the cleaner fishes. The Food Safety Authority launched a cleaner fish campaign. This was conducted with inspections between 2018 and 2019. And what they found was that there were actually breaches of legislation in 64% of the hatcheries. There was a lot to do with infection and disease, which I'll get back to. Also, the handling of acute mortality events was problematic, because despite the fact that cleaner fish farmers register these incidents that cause increased mortality, the inspection campaign showed that they are not good enough at taking measures to prevent it from happening again. So they register a system failing, for example, but will not take measures to prevent that from happening again. So it was happening over and over again, these large mortality events. And also, more than half of the hatcheries had breaches in the routine for stunning before vaccination. Anesthesia is used before vaccination, that's a requirement, but many fail to use anesthesia because they think it's better not to, despite the fact that they can't document this. So that's also a breach of legislation. There were also breaches in nearly a third of the grow-out farms. That was to do with not documenting survival to the end of the production cycle. Also, insufficient routines for removing cleaner fish at the end of the production cycle. This can be very difficult, and there aren't really any good methods of doing this. So many fish are just left, and some go with the salmon to the slaughterhouses. And there are also insufficient routines for killing diseased fish. Now, one of the most interesting findings was that through each production cycle, there is actually about 40% documented dead, about 40% mortality through the production cycles. But the really interesting thing is that the rest are actually unaccounted for. So in practice, that means that it's likely that there is 100% mortality. And one thing that was quite interesting in this report from the Cleaner Fish campaign was that the high mortality levels were sometimes described as the fish not adapting to the production conditions, which, when you think about it, I would say that for any animal where the production conditions, well, for any animal, you need the production conditions to adapt to the animal and not the other way around. Now, potential explanations for this, these unaccounted for fish, is that they could be dead and lost. They are quite small fish, and sorry, but they do rot and dissolve quite quickly, so it can be very difficult to know what happens to them after they die. They could have escaped. They are smaller than the salmon, and it has been known that the size of the net can sometimes be too big, and that the fish can actually fit through and escape. It could be that they end up at the slaughterhouse and that they just aren't documented. There's no registration when they get there because there's no system for handling them. And it could be predation by salmon because these fish are obviously smaller, and especially in starvation periods, it could be that the salmon are actually eating them. Now, in a different study a few years ago, it was attempted to look into why these fish die in grow-out sites. And for more than half of them, it wasn't possible to set a diagnosis, which is unsurprising. As I mentioned, they are small and it can be very difficult to even find them once they die. For about a fifth of them, wounds and fin rot was set as the reason for the mortality. Now, fin rot is linked to bacterial infections, and cleaner fish have been described as sponges that can just absolutely absorb all kinds of pathogens. And it's just incredible how much disease you can find in these tiny fish. So it's not surprising that bacterial infections stood for about 14% of the mortality. Mechanical injuries at 6%, which is also something that can lead to bacterial infections because injuries will cause an opening where you can get pathogens into the fish. Then you have sexual maturation. Sexually mature fish are very vulnerable to handling stress, and they can usually die in connection with or right after stocking into salmon cages. Once sexually mature, they can also be more vulnerable to disease. So that is something that can be repeated a bit. Also, other likely causes of mortality could be starvation. They do need feed, even though some of them eat lice. They do need feed in addition to this. Predation, as I mentioned, can be a problem. This is quite an important point because we don't know how common it is. We do know that cleaner fish are eaten by salmon, but there is no statistic saying how common that is. And it is quite an important question because it is illegal to feed live prey, but we do stock these smaller fish together in a cage with potentially their predators, essentially. So that is quite an ethical dilemma. High water temperature, as I mentioned, and escapes, and strong currents can also be quite a problem because these are not very strong swimmers, so they can very easily get stressed and get exhausted if the currents are very strong. Now, following this Cleaner Fish campaign that was published earlier this year, the Food Safety Authority made it clear that the situation is unacceptable. They stated that producers must register mortality and improve handling routines. They must take measures to prevent mortality events, and they must document a significant improvement in survival and welfare. And what they said was that if it turns out that these measures do not provide a significant improvement, then they believe that the use of cleaner fish must cease in whole or in part. So this is quite interesting, and this will be very interesting to follow up in the future. So how effective are they? This is one area where we come to a bit of a plot twist in our story. There is, in fact, a lack of evidence base. One study published earlier this year said that while much of the evidence is promising, there's a mismatch between the current evidence and the extent of use by the industry. There are actually very few studies investigating the delousing effect, which can be a bit surprising considering they're used in very high numbers, and we still don't even know how effective they are. There are variable results in these studies. Some studies show a 28% increase in lice numbers when cleaner fish were used, and some show 100% reduction. So it can be very variable. In addition, the evidence is quite weak because the studies are usually non-commercial studies in a small scale, so it can be very difficult to compare to actual commercial production. In a national scale analysis looking at purely at data from fish farms, it was found that cleaner fish stocking events on average led to no reduction in louse levels. What they did find, however, was that cleaner fish stocking events did slow louse population increase, but when you looked at this averaged across the industry, it was a very weak and short-lived effect. So you can say that while many sites have positive results from using cleaner fish, nearly as many sites don't have a positive effect. And even after stocking cleaner fish, most sites still had to delouse, even when very large numbers, such as tens or hundreds of thousands of cleaner fish were used. So you can question how effective they actually are and whether there is any use of using them and putting them through this. So why wouldn't they work? It kind of makes sense that you put these small fish in the sea cages and they like to eat lice. Why wouldn't that work? It's been suggested that the salmon and cleaner fish prefer different swimming depths and that they don't perhaps have as many interactions as we thought they did. In addition, we know that cleaner fish prefer other food sources than sea lice. When you look at the stomach contents of lumpfish, you find that the most common food item that you find in their stomachs is actually fragments of salmon pellets. And it has been found that they do probably prefer algae and mussels growing on the nets to eating sea lice. We know that cleaning is a learned behavior, so it's not something that they perhaps naturally do in very high numbers. And even when you look at stomach contents of large groups of lumpfish, you find that few of them eat lice. In some studies, at most, it's been found that 15% had sea lice in the stomachs. And in other studies, it's been found that 28% at most had sea lice in their stomachs. So the vast majority of lumpfish in those studies were found to have no lice in their stomachs. So they are pretty much being kept in an industry where their welfare is very poor. There's probably a 100% mortality rate, and it's for no use whatsoever. So how can this story end? Is it possible for everyone to live happily ever after? It's no surprise that I would suggest to avoid the use of cleaner fish. The salmon lice problem is created by an industry which aims to produce a high number of individuals in an open system close together. Any biologist will tell you that we have created a salmon lice paradise with plenty of hosts for them. One suggestion has been to just better place the farms, to move certain farms. And the director of research at the Institute of Marine Research in Norway has suggested that the currents in the fjord and on the coast are almost, they create motorways that carry salmon lice and viruses from farm to farm. And some of these facilities actually act as the main crossroads and spread the infection further. So if you could move these crossroads, then you can stop the spread of salmon lice and viruses from one farm to another. And that could potentially be a very good strategy for controlling salmon lice. There are preventative measures that I mentioned. And also there are alternative strategies for removing lice. Now, these are often quite poor for salmon welfare. So that's something that needs to be worked on before that's a good solution. But until the problem is solved, the main answer should be reduced production and certainly no increase in production until you can figure out this salmon lice problem. Now, one method of improving welfare for cleaner fish, not ensuring welfare, but improving it, is vaccination. As I mentioned, one of the main welfare issues for cleaner fish is disease. It's actually quite a major problem for the industry as well, because one problem is that many of these cleaner fish suffer and die, but they are also quite a big risk. When you collect all these wild wrasse along the coast, they can bring all kinds of disease into your system, which can be detrimental. So vaccination is key for those diseases where you have a vaccination, and it must be done while the cleaner fish are sedated. Now, even though you have sedation, vaccination is still quite a big welfare concern for these fish, so it's not a particularly good solution. And also there are many diseases where you have no vaccine. And some pharmaceutical companies find that working on vaccines for cleaner fish are not so profitable because they just aren't, there aren't enough of them. They aren't produced in high enough numbers that it is worth the investment. So this is quite a big problem. Feed is important, especially for lumpfish. They can easily suffer from malnutrition. They can't survive just grazing on sea lice alone, and they need supplemental feeding. And we know that a lot of farms haven't been doing this. In recent years, there have been improvements. In the beginning, they weren't fed at all, but now most do. But we do know from the Cleaner Fish campaign that many still don't feed their cleaner fish. Shelters and hides are crucial. I just have an image here of a shelter using sort of an artificial kelp kind of environment. There are many different designs used, especially for the different species. Wrasse requires slightly different shelters than lumpfish. For lumpfish, they have a suction cup basically on their stomach. They have one fin that has evolved into a suction cup that they can attach to surfaces. As I mentioned, they are quite poor swimmers and they do need to rest, so it's very important for them to be able to attach to a surface, such as in a shelter or a hide. One way of improving cleaner fish welfare would be to ensure that they are removed before delousing treatments, especially for thermal delousing. This is a major problem. Thermal delousing is when you use hot water to remove salmon lice from salmon. And this is based on the principle that neither salmon or salmon lice can actually handle the hot water very well, but salmon can survive for longer because of its larger size. We do know that thermal delousing uses water that is so hot that it causes pain for salmon. They get a panic reaction and they injure themselves in a desperate attempt to get away. So we know that it's a major problem welfare-wise. Now, cleaner fish are much smaller in size, and they are likely to be more affected by the hot water than salmon. They also have this suction cup, and one of their stress reactions is to attach to a surface. So they actually risk going through several treatment cycles in this burning hot water. So that's a major welfare issue. And as I mentioned, removing cleaner fish from the net pen is actually quite difficult. And it can take days, even with very good equipment and skilled personnel. You're still not able to remove all of them. So that is a major welfare issue. Now, in conclusion, even if we could solve all these problems, is there any hope for our happy ending? One of the problems is that we have very differing biology on these fishes. Wrasse usually live near the coast. They are very associated with the substrate in plants and kelp on the seafloor. Lumpfish, they like to live near rocky shores and tidal pools when they're young, and later they, even though they're out pelagic in the open sea, they do like to associate with things like floating seaweed and such. Now, salmon, on the other hand, are completely different. They are pelagic. They inhabit the open sea. Wrasse and lumpfish are slower swimmers. They can't handle very strong currents, whereas Atlantic salmon are built for speed and for endurance. Now, when these needs come into conflict due to the commercial value simply, the salmon will always win. And so it's a very uncertain future for cleaner fishes. But I feel like depending on our actions today, it's up to all of us to determine whether this will turn into a horror story or be a fairy tale with a happy ending. Thank you very much.
Thank you very much for that talk, Susanna. We've got lots of questions that have come through in the Q&A box, so we'll get started with those. The first one is, great talk. I've heard that lumpfish need access to live seaweed. They have special skin cells that take up the mucus from the kelp, which gives them borrowed immunity. Is there any more information about this obligatory need for environmental enrichment?
Wow, what an interesting question. I've actually never heard of this before, so I'm afraid I can't answer that. They do need access to shelter, and they do need to be able to attach to a surface. But this thing about skin cells and needing live plants, I've never heard of that, and it's not something that's done in commercial aquaculture. They are not provided with live plants.
Thank you. Next question. What is your opinion on the best method from a welfare point of view to eliminate sea lice?
Yeah, that is a good question. If I had a good answer for that question, I would be a millionaire. There are so many people working on this. As I said, this is the main motivation probably for the aquaculture industry at the moment. There are ideas popping up all over the place. I think that the most promising intervention that I've heard is what I mentioned about better placement of the farms. I think that would be a very elegant solution that would at least help with the problem. It wouldn't solve it, I don't think, but it would help. So I think that would probably be the best solution. And as I said, there are just a lot of hosts put together in open systems in a small area. So it is a dream situation for the sea lice.
Thank you. From Anna Valentin, thanks for the talk. In a previous presentation, it was referred that wrasse and lumpfish were not an efficient way to eliminate salmon lice, and so not practical due to the high number of cleaner fish needed. The manual removal of the lice, what is your experience with that in Norway, and is this the most used method to control salmon lice?
Yeah, cleaner fish are very common. They are used pretty much all over in Norwegian aquaculture. But another very common method is the one I mentioned, thermal delousing. which is a major welfare concern. It is the most common mechanical method, non-medicinal method of removing salmon lice. And it has been found earlier this year to be causing pain in fish. Actually, it was earlier last year, but the publishing has continued throughout this year with more and more studies showing that this delousing is actually painful and causing injuries for the fish. And just recently, a paper was published saying that it's actually the injuries come from the fish panicking because they are desperate to try and get away. And even when sedated, the hot water will wake them up and cause them to injure themselves. So this is a very, very painful procedure, which is very problematic.
Next question from Pablo. Great talk, thanks. I was wondering if farmers are selecting lumpfish breeders regarding the delousing effectiveness. I mean, they might select those individuals that have learnt or predate on sea lice. Do you have any evidence or experience about this?
Thank you, Pablo. That's an interesting question. Breeding of lumpfish is still very much early stages. We still collect roe from the wild, but there have been studies looking into different families of lumpfish. I briefly mentioned that with the studies looking into how many of the lumpfish stomach contents contain sea lice, and those studies, some of them are looking into different families to see if they can be bred. And there are differences between the families. So there does seem to be a genetic component. But as I said, even the best families, you get 28% of them with sea lice in their stomachs. So it's still not very effective.
Next question from Lynn Snedden. Great talk. Is there a humane way to treat lice, or should we stop farming salmon the way that we do? Further climate change is making our waters warmer, and this could explain why lice flourish. Should we transport farms further north, or would the problem persist?
Thank you, Lynn. That's a brilliant question. So far, I don't know of any humane ways of treating salmon lice. There are ways of preventing salmon lice, and obviously prevention is the best method. When available, there are skirts and there are different other preventative methods being used. And yes, of course, it is that the waters are getting warmer and more beneficial for salmon lice, so that is a struggle. It will be an issue. I think it would be very short-sighted to think that moving farms further north would solve that problem. You would just get an arms race of lice that can handle colder water. So I don't think that's a very sustainable solution, I'm afraid.
From Pablo, could farmers teach lumpfish at hatcheries how to feed on sea lice? What do you think about this?
Actually, yes, they are already looking into that. It's been found, there have been studies looking into whether feeding with live prey, like live zooplankton in hatcheries, can actually be beneficial. There are studies looking into that at the moment. So that's a very interesting method of improving the efficacy. I don't hold out very much hope for that. And even if you could improve how many sea lice they eat, that's not really improving their welfare, and it's still a huge welfare issue. Basically, every day there are about 150,000 cleaner fish dying in Norwegian farms, and that's just too big of an issue to solve, or too big of an issue to just be happy with them being more efficient at eating sea lice.
A question from Lucas Jaswinas. Thanks so much. What a terribly overlooked issue. Is the use and thus farming of cleaner fish as developed in other salmon farming countries too, for example, Scotland, Chile, etc.?
That's a very good question. I work only in Norwegian production. I work only with Norwegian production. So I can't say for sure. I do know that other countries use cleaner fish as well. They are used, for example, in Scotland, and they are used in the Faroe Islands. Whether they are used to the same extent, I don't know. Seeing as Norway is the #1 producer in the world, I would say we probably have the largest cleaner fish industry. but I won't be too sure about that.
From Sunil Kadri, fabulous talk, Susanna, congratulations. Better placement means offshore, I guess. What about the various closed containment systems that have been developed and pump water from deeper down?
Better placement could mean offshore, yes. Thanks, Sunil, by the way. There are different closed and semi-closed containment systems being developed. Some show more promise than others. One of the main problems with them is that when they work quite well, but when they fail miserably, and you get millions and millions die in acute mortality events. So it is still very risky, and even though you have better control of the production, that could still come at a cost for salmon who are now inside a closed system and not getting the same stimulation that they would in open sea cages. Offshore sites are still a bit of a question mark. It could be quite detrimental if the currents are too high. Even for salmon, they do have their limits, and keeping cleaner fish out there would just be very destructive for welfare because of the very high currents. And also these offshore sites usually have very high numbers of salmon in single sites, which means that they are very vulnerable. If you get an acute mortality event, you will have millions and millions of fish die within possibly hours or days, and that would be terrible.
A question from Anna Valentim. Do you think if the thermal method can be done with full anesthesia and not only sedation, do you know if the studies you referred to assess long-term effects after exposure?
These studies were done with full anesthesia, but the problem was that the fish were waking up. They were even put into special bags so that you could measure only the effect of the temperature, so that the fish wouldn't injure themselves. But the researchers couldn't do that because the fish were waking up. It was so painful that they were panicking, even though they were under anesthesia. In this study, they weren't able to look at long-term effects because all the fish were killed directly after the event. But when you look into mortality long after these thermal delousings, you do find that there is acute mortality after the event. But after that, I'm not so sure that anyone has really looked into it in a proper controlled study, because out in the sites, a lot of other things happen, so it's very difficult to control.
Anonymous question. Is anyone concerned about the welfare of the sea lice?
That is a very good question. I have had that question raised before, but I haven't heard anyone actually speaking up for sea lice. So not as far as I know.
A question from Paul Dennekamp. Are salmon producing companies working on more fish-friendly methods for protection against the sea lice?
Yes. There are many companies working on many different methods. And of course, all will say that their methods are welfare friendly. There is a requirement in Norway that you're not allowed to use methods before it's been documented that it's acceptable from a welfare perspective. However, we do use thermic delousing that slipped through the cracks, and other mechanical delousing systems are also quite detrimental for welfare in some cases. So yeah, I don't think that we have a very good solution yet, but those working on prevention I'm most hopeful for.
A question from Phil Brook and Alison Mood. Does the laser system work?
Now that is that is the best question. We don't know. There are no thorough studies looking into this. Nothing has been published assessing the effect of lasers. It would be a brilliant solution if it worked. I can't say for sure whether it does or doesn't. I know that there is some work underway to develop studies to look into it, but as far as I know, this hasn't happened yet. I would be very happy to recommend LACEs once there's a study that documents the effect, because they do seem to be quite good from a welfare perspective, but we simply don't know yet.
Next question, anonymous. Are the thermolyser treatments considered as a last resort? Are other treatments all carried out first?
That would be good. Unfortunately, I can't say that that is happening. When I speak to the industry, one of the main things I hear is that there are so many considerations to put together in this risk assessment and in determining a good plan for sea lice. So what happens is that a lot of the time, the producers will use the equipment that they have available for them, unfortunately. And if that is thermic delousing, then that is what they will use. Some do have better plans and a more sustainable outlook, looking a bit further into the horizon. But sometimes unfortunate events happen and you need a very quick delousing, and it is easy to grab the equipment that you've invested in or that you have available to you.
Thank you, Susanna. We have about 4 minutes left before the end of this session. So I'm just going to pause for a moment to give anyone else a final opportunity to ask any last questions. Okay, well, that brings us to the end of this session. Thank you so much for that very interesting and insightful talk, Susanna. Talk of fairy tale or nightmare, we're not sure which, but very interesting. So thank you for joining us. And so next up for the conference, we have a lunch break, which will then be followed by a talk, which is starting at 2 p.m. GMT by Jay Schuster, which is entitled "In Advancing Fish Welfare Through False Advertising Lawsuits." So that's it. Enjoy your lunch, everyone. Thank you.
Thank you.